Hello everybody. I decided to go live again because in our previous session there was only um, 30 minutes and I don't know, the internet got messed up and I was about 1 hour talking and it only happened to be 34 minutes. And the other topic that I was tackling was recursion. We tackled modules and functions and now recursion. And it seems Elixir does not provide loop constructs, so they rely on recursion and high-level functions for collections. And here's an example for C for loop, if you're into that. And they start quickly with explaining recursion. I want to repeat something that I did say in the previous session because I suppose that was some sort of important. So I was thinking that I don't know how recursion looks in the nature. How can you visualize recursion, in the nature? I said that, and I'm saying it again, just in case. I will give one thought or two thoughts. Now we have this module recursion. It is receiving a message, one message parameter and n parameter and number. Here is a word. It has to be greater than 0. Now it calls itself, look at this, multiple times. Imagine an arrow going down over here, step by step, until you reach this point, and you make this arrow spin and arrives over here again with a less reduced number, okay? So an arrow down, spinning arrow, and you're having this sort of loop until you reach number 0, which then happens to be over here. For 0, they only have OK, so this will be called even if you pass 3, 4, 5, okay? And then we were saying that we are in this code, there is this function clause that is missing, in which what happens if n is less than 0, you will hit a function clause error. But then again, it was mentioned over here, okay? We tried to fix it in our previous session. Alright. Well, it is already mentioned. So we do have the code because we exercised the thing. We also opened Visual Studio Code with a mix project, and it was a good session, but somehow it got messed up and it was good on half. So in here we fixed we added for n minus less than 0. No bueno, n must be greater or equal to 0, and it doesn't have syntax highlighting, just that Visual Studio Code doesn't provide syntax highlighting. For one file, it seems like it requires a mixed project to be present. Not sure about that, unless we do experiment with Elixir LS in this instance in the Windows subsystem for Linux. So not much to say. Okay, hopefully you get the recursion right. In the previous session, we mentioned how you can run your code. And this underscore is because we are not using message, so the compiler and the interpreter doesn't get mad or say something. And then we reach the reduce and map algorithms. Let me see the time. 5 minutes. Then we reach the reduce and map algorithms. And look at this. It says it receives a list, head, tail. Why? Because it is the bracket. And an accumulator. And it calls itself. It will recurse. There is a recursion call. Recursive call. And it has tail at least. List. Tail is a list. So it type checks. And the head, the element, plus the accumulator. And we have the function clause when the list is empty. And the accumulator, we just return the accumulator. And this is how you invoke that function, how you call that function, list and the accumulator, and you get 6. And you can exercise the recursion calls and see that 1, 2, 3, 0, 1 plus 0, 1 plus 2, 3 plus 3, empty list, 6. You can do it on your notebook. When the list is empty, okay, then we have double each, which again, look at this, receives a list with the same pattern, head and tail, with no accumulator. Head, tail, accumulator, head, tail with no accumulator. Head times 2, it will double each element. And in here we have a nested recursive call, if you will, if you want to say so, but it is a recursive call. But this recursive call with a tail, which is a list, tail is a list, will produce another element for the resulting list. Look at this, we have the resulting list. Look at these beautiful brackets. So the first element will be head times 2. And then we have the inner, if you will, recursive call. So it can produce another head times 2. Okay. And if it is an empty list, you return the empty list, which eventually will be here, and it will be consified, quote unquote, with the other elements that were produced. 1, 2, 3, 2, 4, 6, okay? And it says that doing quote-unquote vanilla recursion is not the way they do it on Elixir, so they come up with some module called enum. Okay, and they also mention type call, which is important, but they do care about that in Elixir. If you're not studying computer science using Elixir, but instead you're writing applications, they have taken good care on writing this module, and it is optimized with these type calls. So you don't need to worry about that, just using the met functions inside this module, which was explained in a previous session. And then we have this reduce, which is called fold sometimes. 1, 2, 3, the list. It receives a list, an accumulator, and a function receiving the element of the list, the accumulator, and how are you going to process? How are you going to combine the element with the accumulator? And in here they are just summing or performing an addition with these two. So 0 plus 1. The new accumulator will be 1. And then we have this famous function map, in which you take a list and a function, and this function will take each of these elements, and will process it as specified in the body of the function. Okay, we can copy and paste. And then write the I character, and and what happens here is that this will tell you the information about the expression, and it is being evaluated, so it is giving you the term, which is the result of this evaluation, 2, 4, 6, and its list, its data type. Okay, so for map you will always have a list, probably in the new. Let's click over here. If you look at the source code for Elixir, probably tomorrow we can take a look at the source code, Elixir's source code. And in here, you will always end with a result type of list in map. But in reduce or fold, you can, the accumulator can be a list, or it can be of any other given data type, perhaps an integer or a 3 if you are in the, if you are like writing some computer science algorithms. And that's reduce, and that's map. There are other famous functions. You see all of these chunk concat. They have a lot of these. Let's see if they have filter. Yes, this is the other famous ubiquitous, that accepts a predicate. So let's take a deeper look at enumerable, and while we are at it, its lazy counterpart, stream. So in our next session, we'll be taking a look at enumerable and its lazy counterpart, stream. So this was explained in half an hour. Right now, it seems like I am kind of bored or low energy, but I am reserving my energy to my guitar practice session later, and perhaps some mathematics videos. So that's why I probably sound like, oh my god, this guy is sleeping, falling asleep. But no, we already did this at the modules and functions. Tomorrow we will be taking a look at these enumerables and streams. That's it for our today. Let's wait for the time to be 15 minutes. and say goodbye. We are not, let's see, we are not taking a look at processes. It is important in Elixir, but you can do it on your own. Probably we will be taking a look at this and structs. And these are like the interfaces in Elixir protocols. comprehensions should use, because these are used in the Phoenix Web framework. We have to take a look on, of course, how exceptions are being handled in Elixir. Documentation is important. Erlang, we are not integrating with Erlang directly. And debugging is important. Probably testing, where is it? Macros are important. What is testing? Most likely will be over here. Yeah, thank you very much, and hopefully you got something from this short version of our previous session, of the last part of the previous session, which was thrown to the trash. I don't know why. Thank you very much. Bye.